So next, we're continuing naming alkanes. And if we have, we want to find the longest chain of carbon. And if you have two options, so let me show you what I mean here. If I choose to number it like this, 1, 2, 3, 4, 5, 6, 7. So we have that chain of 7. So just to make sure that is the longest chain, we have 1, 2, 3, 4, 5, 6, 7. So we have two ways we can go. And they're both 7 carbons long. So we want to pick the chain that has more substituents. So for this chain here, we only have one substituent. We have isopropyl. So the isopropyl is this right here, okay? But if we go the other direction and number it 1, 2, 3, 4, 5, 6, 7, we end up having a methyl group here and an ethyl group here. That wasn't a very good circle. Ethyl group here. So we have 2 substituents with this chain. So that's the one we want to pick. We always pick the one that has more substituents for it. Okay, the next rule is if we have substituents that are the same distance at both ends. So that's the case here, right? When we're trying to number, we always want to pick the side where the substituent is closest to the end, but here we have a methyl group and another methyl group, and they're the same distance, right? So we want to start numbering where it's going to give the third substituent. So here's the third one, where it's going to give it the lower number. So just to show you, if I number here 1, 2, 3, 4, 5, 6. Or if I go the other way, 1, 2, 3, 4, 5, 6. So if I use the numbers in red, then that methyl is on carbon 4. But if I use the numbers in green, that methyl is on carbon 3. So that's the one we want to go with. Okay, we want to give that second substituent the lower number. So the green one wins, right? So we've got a methyl on 2. We've got a methyl on 3 and a methyl on 5. So we're putting all those numbers and we're separating them with commas and then a dash. And then since we have 3 methyls, we've got to say trimethyl and then hexane, trimethylhexane. Okay, and here's just a summary of what we've talked about. So first thing we want to do when we are naming a molecule, we want to find the longest chain and identify that parent name. So, it's going to be methane, ethane, propane, butane. So that's the first thing we have to do, find the longest chain. And then we identify the substituents. And then we alphabetize the substituents, and because we want to list those first. And if I have multiple of the same substituent, then I'm going to use di, tri, and tetra, depending on how many I have. And we're going to label each substituent with which carbon it is located on. We separate those numbers with commas. So if I have several methyl groups, I need to separate the numbers with commas, even if it's on the same carbon. So let's say, just to give you an example real quick, let's say we have something like this, and we have 2 methyl groups right here. Okay, so I would name that, so it's butane, right? Because I have 1, 2, 3, 4 carbons. And then I have, 1, 2, 3, I should number them, 1, 2, 3, 4. And then I have 2 methyls on carbon 2. So I'm going to put 2 to show where they are, and then dimethyl, and then butane, use the parent name. Okay, so even if those methyls are located on the same carbon, I still have to write the number for each of them. And separate numbers from letters with the hyphens. Okay, so that's just, a summary of what we just talked about. So now we're going to just do a bunch of examples. Okay. So again, we want to first find the longest chain. Oops. That's not what I meant to do. There we go. Okay, we're going to find the longest chain. So I'm going to start on this side here because that's where the substituent is closest to. So 1, 2, 3, 4, 5, 6, 7. So we have a 7 in our chain. There's really no reason to start counting from this one because it's not as long. But we have a methyl group there on carbon 3. So we're going to start with naming that substituent. So we're going to say 3-methyl. And then we're going to name the parent chain. It's 7, so it's heptane. Okay, so 3-methylheptane is the name for that one. Okay, now we can come over to this side, number 2. So we want to start numbering over here, right? Because we have these 2 methyls together. So we're going to start numbering 1, 2, 3, 4, 5, 6, 7, 8. Doesn't really look like a 7. Let's try that again. 7, 8. Okay, we have 3 methyl groups. So we have 1, 2, 3 methyl groups attached here. So we've got to start by putting our numbers. So we have 2 on carbon 2. So we're going to put 2, 2. And then I have 1 on carbon 6 dash methyl. Oh, not methyl. Trimethyl, sorry. Trimethyl. Oh, I ran out of room. Let me back up real quick. Let's see if I can write a little bit smaller. So 2, 2, 6, trimethyl. And then there's 8 carbons, so it's octane, trimethyl octane. So that's the name for that molecule. Okay, and then we come down here to this one. Okay, so we need to find the longest chain. So we're going to start, well, let's just number and see where we get. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's one option. So here we have 3 substituents. We have methyl, methyl, and terp-butyl, sorry. Terp-butyl there. Okay, but let me show you here. This one can be kind of tricky because if I number this way, 1, 2, 3, 4, 5, 6, 7, 8. So I still have 8. But here, this gives me more substituents, right? So I have 1 methyl here, 1 methyl here. I have an ethyl group here, and a methyl group here, and a methyl group here. So overall, I have 5 substituents where in the previous chain, I only had 3. So we want to choose this, this direction right here. That gives us the longest carbon chain with the most substituents. So those can be a little tricky. You just have to be careful, make sure you count. Okay, so now we're going to put in the substituents. We want to start with ethyl because that's alphabetical order. So ethyl is on carbon 3. So we're going to put 3 ethyl, 3-ethyl. Okay, and then we're going to put methyl in. So we've got 4 methyls. We've got 2 on carbon 2, so we're going to put 2, 2. Then we have 1 on carbon 3 and 1 on carbon 7. So I've got to put all those numbers in. And since I have 4, I'm going to say tetramethyl. Tetramethyl. And I'm going to run out of room, so I'm going to write it down here. Octane is our parent carbon chain. So 3-ethyl 2237. Oh, I forgot my dash. No, that doesn't look very good. Dash. Tetramethyl octane. So always put a dash in between numbers and letters to separate them, and then separate the numbers with a comma. Okay, let's keep going here. So on this one, the longest chain is going to be right here. Whoops. Let's try that again. Okay, that's going to be the longest chain because we're going to get 1, 2, 3, 4, 5, 6. Oh, I'm going the wrong way. 5, 6, 7, 8, 9. So 9 carbon in that chain. So if you count any others, you're not going to get 9. You'll get less. So we want this as our chain. And we want to start counting on this side because we have this methyl group attached to carbon 2. So if we started over here, the methyl group would be, if we started counting right here, it would be on 3. So we want to start over here. Okay, so we have methyl there. We have another methyl here. I'm trying to circle that a little better. We have a methyl here. And then we have an ethyl group here, right? 2 carbons there. And then look at this one here. We have 4 carbons, so 1, 2, 3, 4. So it's butane, but remember it's alkyl, so we take off an H, so it's butyl. But if you'll notice, the carbon, the secondary carbon here, is attached to the parent chain. So we're going to call it sec-butyl. Okay, so we're going to start in alphabetical order. So that means we'll start with butyl. So we're not going to consider the prefix sec or iso or tert in the alphabetizing. Okay, we're going to start with the alkyl name, so butyl. Okay, so it's going to be on carbon 5. So we're going to do 5 sec, and we put a dash butyl. Okay, and then we're going to name the ethyl. So it's on carbon 3, so 3-ethyl. And then we come down here because it's getting long. We have 2 methyl groups. One's on carbon 2, one's on carbon 7. So we're going to do 2, 7 dash. And it's going to be hold on, I'm making sure. Okay. It's going to be dimethyl octane. I wrote it down on my notes wrong, so I'm making sure I'm saying this correctly. Dimethyl octane. Not octane. I'm looking at the wrong one. I'm sorry. Dimethyl nonane. There's 9. Keep looking at the next one. Sorry. Okay, so 5 sec butyl, 3-ethyl, 2,7 dimethyl nonane would be number 4. Okay, last one. So we're going to start numbering. We're going to start numbering over here because this is where everything is. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here we have 3 substituents. We have isopropyl there and 2 methyl groups here. Okay, but let's just check. Make sure that's our only option. So what if we start numbering here? 1, 2, 3, 4, 5, 6, 7, 8. So it's the same amount of carbon, but it gives us more substituents, right? So here we have 3 ethyls, or 3 methyls, 3 methyls and 1 ethyl. I was looking at the ethyl and not the methyls. Okay, so 3 methyls and 1 ethyl. So that gives us 4 substituents where If we had numbered it the other way, we would have only had 3 substituents. So just be careful with that. Sometimes these get a little tricky. Okay, so we're going to start with naming our ethyl because that's first in alphabetical order. So it's on carbon 3, so 3-ethyl. And then we have 3 methyls. We've got one on carbon 2, carbon 4, and carbon 5. So 2, 4, 5. We're going to separate those with commas and then dash. And we have 3 of them, so it's going to be trimethyl and 8 carbons, so trimethyl octane. Okay, so we went from the structure to the name. Now let's go from the name to the structure. I'm going to switch over. No, I think I can do it here. Never mind. Okay, so first we have 2,2-dimethyl propane. So I like to start off with, drawing the parent chain. So I have propane as the parent chain. So we have, and I like to draw the line structures, 1, 2, carbon there, 3, right? So we have a carbon, carbon, carbon. So 3 carbons for propane. Okay, and then it says 2,2-dimethyl propane. So I'm going to have 2 methyl groups on carbon 2. Whoops, I totally missed it. So I'm going to have one here and one here. So that looks a little funny in the line structure. So I'm going to draw it again in the condensed formula. So CH3, C, CH3, and then I'll have CH3 and CH3. So it looks like that in the condensed formula. So if I don't specifically ask, either one is fine, but I think I mentioned this earlier that your lab book is specific, so make sure you pay attention to that. Okay, then we have 5-sec-butyl 2,7-dimethyl-nonane. I'm pretty sure we just drew that one. That's okay. We're going to go from the name to the form, or to the structure. Okay, so we're going to start out with nonane. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon. Okay, and we're going to start with 2, so 2-dimethyl. So I'm going to have a methyl here, and 7, so 3, 4, 5, 6, 7. So here's 7. We're going to have another methyl, and then carbon 5 has a sec-butyl. So remember, sec-butyl just means that the secondary carbon is attached to the main parent chain. 1, 2, 3, 4, 5. So here's 5. So we're going to have 1, 2, 3, 4. Sorry, that doesn't get right there on the line. 1, 2, 3, 4. That's a little better. Okay, so that would be sec-butyl. Okay, then we have 5-ethyl 2,4,6 trimethyl-octane. So I'm going to start by drawing octane. So we have 1, 2, 3, 4, 5, 6, 7, 8 carbon and octane. And then we have lots of methyl groups, 2, 4, and 6. So I'm going to start down here. So here's 2. Oops. 2, and here's 4. And here's 6. So that's where the methyl groups go. And then ethyl is going to go on carbon 5, which is right here. So we're going to have 2 carbon on ethyl, 1 and 2. Okay, so there is our 5-ethyl 2,4,6 trimethyl-octane. Okay, last one, we have hexane. So I'm going to do it down here. 1, 2, 3, 4, 5, 6. Hexane has 6 carbon. And then we have a methyl on 2. So I'm going to put it right there. Methyl on 2. And an ethyl on 4. So we're going to need 2 carbons, 1 and 2. Sorry, kind of ran out of room there. Okay, so that's just to show you how we can go from the structure to the name and from the name to the structure. So be able to do both of those.